what are the challenges? So we are constructing a lot of tall buildings which require concrete grades as high as M80 and in some cases M100 as well. So what are the challenges in production and transporting to the actual place of site? So these days what we have is a control on the temperature of the concrete at placement. So typically it can vary between 25 to 30 degrees Celsius. So this depends upon the project specification, which is drafted by some structural designer. And especially in case of raft where there are mass concrete. So if you are having a section more than 900 mm, so it is typically comes under mass concrete classification. And what we say is for most of the tall buildings we are coming across in Mumbai and other places like Hyderabad, so the depth of raft is approximately around 3 to 4 meters. So that is a sort of depth you are encountering. So and also not only a raft element, but also if you are having a core wall or a large column, say we are constructing a building where the column dimensions around 2.5 meter square cross section. So all these come under mass concrete category and we are required to place concrete at a very low temperature. And if it is a residential locality where there is already a good residential population, some nighttime concreting is not permitted. So we have to pour during the day. So during the day, you can imagine at this point of time, the temperatures are as high as above 40 degrees Celsius. And in some parts of India, it's already crossed 44 degrees. And adding to this thing, if you're going to do during the day, there could be traffic restrictions, including the availability of parking spaces for the transit mixers. So if you're having a large pour, say 100 m cube or more, you need to have the concrete supply continuously so that your pumping activity goes on uninterrupted. So this is compounded by in cities like in Mumbai, where there's plenty of infrastructure development also going on. A lot of metros are being constructed. So there is a lot of movement of construction equipment and also a lot of movement of transit mixers. So there is restriction on the movement during the day and also during the peak hours. And also what RMC suppliers, the ready-mix concrete suppliers face is, they are having plenty of orders from customers and especially for high-strength concrete, and they have to deliver the concrete in a short period of time. So during the available window, they have to produce the concrete and also transport it. And in case if there is any issue during transport, say a loss of slump, and if the transit mixer is getting delayed at the delivery point, so it has a ripple effect on the subsequent orders. So these are some of the things that we are seeing in cities like Mumbai and Hyderabad. So the big question is how to cool the concrete. So probably the general theme is always pour during the cooler times in the day. So mostly during the night times. But what we have seen during the last year's summer is during the night also, especially in cities like Delhi, the temperature was around 40 degrees Celsius. So there was not much advantage to be gained by doing the pour during the night. So what we have to do is we have to cool the concrete so that we bring down the placement temperature. So we can install ice flake units. So it is not available commonly across India, especially with RMCs. Many don't have these ice flake units. And mostly in very big projects, the contractor typically like L&T, they install the ice flake units because it also needs quite a bit of investment. If an RMC has to do it, it has to invest quite an amount on this thing, a capex amount, and also a space to install equipment. So some RMCs are tight on space as well. And in case if you are procuring ice blocks and if you want to crush it and use it in the concrete, again, it is an intensive manual process where you have to install a crusher and crush the thing and feed it into the mixer machine. But even the availability of ice blocks in a busy city like Mumbai, it could be a challenge because the ice manufacturer, there will be a certain capacity to the manufacturing, and if that orders from the customers exceed their capability to manufacture, so there could be a constraint on that account as well. As I already told, a chilled water plant also needs investment and space to install. So these are some of the measures to cool the concrete that is currently being done in India. Abroad, you might have come across liquid nitrogen being used to cool the transit mixer drum, but it has got its own health and environment safety risk also associated with it. So in India, it's not being tried out. So, but how you can, having said the different measures to cool the concrete, what are the different ways you can improve the placing of concrete? So, placing during the cooler time of day is an option, but also you can design your concrete in such a way that it contains as much of supplementary cementitious material as it can, because when you reduce the OPC content, automatically you can reduce the heat of hydration considerably. So you have to balance the requirement between strength requirement and also the attainment of and also the temperature control you want at placement, and also subsequently if it is a mass pour. So instead of specifying 28 days, you can also specify 56 days or 90 days, especially in the case of foundation elements where you don't require immediate strength at 28 days, because actual full loading is supposed to come maybe after 1 or 2 years. So you don't require such high strength development at 28 days. So in some tall building projects in Mumbai, we are currently going by this 56 days strength compliance. So some of the structural designs are accepted our proposition, and we are able to control the strength in a mass concrete element, that is a peak temperature that develops in a mass concrete. So when you are able to specify the latter age strength development, automatically your concrete also helps in the sustainability costs, and also it is a case for low carbon construction. You need to use less cementitious materials in your mix design, and also the whatever energy you are expending on the cooling process, the embodied carbon in your concrete and also in your final structure also goes down considerably. So nowadays, some clients, especially from abroad, they are specifying global warming potential, a term called GWP, when you are designing the concrete mixer. So it has to meet that global warming potential criteria as well. So to cool the temperature, you can use a combination of either ice flakes, chill water, and also you can reduce your OPC content to see that the heat of hydration is controlled in a mass concrete element. So these are some of the things which I wanted to share with you, and I would like to thank you for this opportunity.